Question 11. Part A. Use binomial expansions, so plural, could be important, to show that the square root of 1 plus 4x, all divided by 1 subtract x, is approximately equal to 1 plus 5 over 2x subtract 5 over 8x squared. After that, we then need to talk about why x equals a half shouldn't be used for an approximation, and then how would we actually find an approximate value for root 6 using this expansion. But let's start with part A. Our first mission in part A will be to separate this root into separate components that we can expand separately. So let's consider 1 plus 4x divided by 1 subtract x. That's the same as root 1 plus 4x divided by root 1 subtract x. This means it's 1 plus 4x to the power of a half multiplied by 1 subtract x to the power of negative a half. This gives us two separate things we can expand using the binomial expansion formula. I'll remind you of it now. This is in the formula book, but just reminds us when we're expanding 1 plus x to the power of n, it's the same as 1 plus nx plus n subtract 1 over 2 factorial x squared, etc., etc. So that can be found in the formula book. So we're going to do this now. We're going to use this to expand each of these separately. So let's start with 1 plus 4x to the power of a half. So that's going to give us 1. So it always starts with 1 plus n, which is a half, times by x, but in this case it's 4x, plus n, which is a half, multiplied by n subtract 1. So a half subtract 1 is minus a half, all divided by 2 factorial, which is 2, multiplied by 4x, all squared. So it's important we put this in brackets, this 4x, common mistake there. You can use a calculator if you want to do the subtract 1 of your fractions, but I felt confident to do that. So simplify this. This is going to give us 1 plus 2x. A half times negative a half is negative a quarter. Divided by 2 is negative an eighth. Multiplied by 16x squared. 4x all squared is 16x squared. So negative an eighth times by 16 is going to give us negative 2x squared. Let's now expand 1 subtract x to the power of negative a half. So that's going to give us 1 plus n, which is negative a half, times x, which is negative x, plus n subtract 1, minus a half subtract 1 is minus 3 over 2, all divided by 2 factorial, which is 2, and then negative x all squared. So what's that going to simplify? So we're going to get 1 again. Negative half times negative x will be positive a half x. Negative a half multiplied by negative 3 over 2 would be positive 3 over 4. So it would be positive 3 over 8. Multiplied by negative x squared, which becomes positive, so we're going to get positive 3 over 8x squared. And now we've expanded our separate components. So therefore our original expression, so 1 plus 4x, all divided by 1 minus x all square rooted, is going to be approximately equal to these two things we've just calculated multiplied by each other. So 1 plus 2x minus 2x squared multiplied by 1 plus a half x plus 3 over 8x squared. Now when I'm going to multiply this out, we're only going up to x squared, so we can ignore the x cubed things. So when expanding this, what I'm going to do is I'm going to layer my answer. I'll show you what I mean. So I'm going to do 1 times all of the second bracket, so you're going to get 1 plus a half x plus 3/8 x squared. I'm then going to multiply everything by 2x, but I'm going to move it along 1. So 2x times 1 is plus 2x. 2x times a half x is going to be plus x squared. And then 2x times 3/8 x cubed. So I'm going to write it down. So that would be 3 over 8 times 2, so 6 over 8, 3/4 of x cubed. But actually, I don't really need the x cubed term, so I'm not actually going to worry about going past this line any further. Now I'm going to do negative 2x squared times 1, which is going to be negative 2x squared. If I do the negative 2x squared times the rest of it, I'm just going to get these things that can be higher than the powers that are required. So let's simplify these rows. So collecting this all together, we're going to see that our expansion is going to be equal to 1 a half x plus 2x will be 2.5 or 5 over 2x, and then 3/8 plus x squared subtract 2x squared. So that will be negative x squared plus 3/8 x squared. So that's going to be negative 5 over 8 x squared. Double check. Yes, that's what we were trying to show. So that's 6 marks for part A. A student substitutes x equals a half into both sides of the approximation above in an attempt to find an approximation to root 6. Give a reason why the student should not use x equals a half. So we were expanding 1 plus 4x divided by 1 subtract x, all rooted. And what we did, the technique is we expanded 1 plus 4x to the power of a half. And we did 1 subtract x to the power of negative half. Now we have a rule for binomial expansion when we've got sort of negative powers or fractional powers, is that the expansion of 1 plus x to the power of n is only valid when the modulus of x is less than 1, or you could say that x is between 1 and negative 1. This is so that your infinite power series converges, so you need small values of x so that it doesn't diverge. In our sequences, we've actually got 4x and a subtract x, so we've got to change something slightly. So we're going to say the expansion of 1 plus 4x to the power of a half is only valid for, so the difference in this one is not just the modulus of x less than 1, it's the modulus of 4x has got to be less than 1. And that implies that the modulus of x has got to be less than a quarter. You could alternatively say, for inequalities without the modulus, you could say it's got to be less than a quarter or larger than negative a quarter. So if you look at that x equals a half, x equals a half is outside this range of, say, validity. Effectively, you can't use x equals a half because the expansion is only valid for the modulus of 4x less than 1 if you're going to get an accurate approximation to that function. Part C, substitute x equals 1 over 11 or an 11th into your expansion to obtain an approximation to root 6. Give your answers a fraction in its simplest form. So first of all, let's sub 1 over 11 into the square root we have and see what happens there. So if x equals an 11th, then the square root of 1 plus 4 times an 11th, all divided by 1 subtract an 11th. So what does that simplify to? So you've got square root of 1 plus 4 11ths, so that's 15 over 11. And then 1 subtract 11th divided by 10 11ths. And so that's the same as the square root of 15 over 11 times 11 over 10. So that's the square root of 15 over 10. So that's the square root of 3 over 2. Now if you write it like this, the square root of 3 over the square root of 2, and you rationalize it, what we end up with is root 6 over 2. Effectively, this is just shown that if we sub 11th into our root, we get an expression that's the square root of 6 over 2. It wants us to approximate root 6, so what we're going to need to do is we're going to need to multiply by 2 to get our root 6. So because the root of 1 plus 4x all divided by 1 subtract x is approximately equal to 1 plus 5 over 2x subtract 5 over 8x squared, that means then if we sub x equals 1 over 11 into our expansion, so we're going to get 1 plus 5 over 2 times 1 over 11 minus 5 over 8 times 1 over 11 squared. This should be approximately equal to root 6 over 2. So if we sub this into our calculator, this means then that as a fraction we get 1183 divided by 968, and that is approximately equal to root 6 over 2. And so therefore, if we times it all by 2, we're going to get 1183 divided by 484. Just double check that, multiply that, you get 968. Yes, and so that's approximately equal to root 6. As a fraction in the simplest form, we get root 6 is approximately equal to 1183 divided by 484.